How is it going? All right, this video, more integrals, and this is basic trigonometric form. Okay, so this is some more stuff you have to memorize. We've got the antiderivative of the trig functions. Okay, now look, there's going to be more integrals with trig functions that are going to be different, a little different than these, and that's in like the applied calculus, the second part of it, at least where I teach. That's what it is. Some of you may that are in the technology programs or whatever you're in that have to take applied calculus, you may encounter the stuff we do in the second part in this first part. Okay, we're on quarter system, y'all may be on semester system, but there is other things where you have trig functions, but this is just the basic trigonometric forms. So, I mean, the bottom line is, you see all these, you got to memorize them. And if you don't memorize all of these, then you're not going to be able to work them. Okay? So basically, whatever problem we have to make it look like one of these. I mean, you're either going to need sine u, cosine, secant squared, cosecant squared, secant tangent, cosecant cotangent, or the rest of them. That's what you've got to make them look like. That's all we know how to take the antiderivative of, and that's what we have here. Now, one of these I want to talk about a little more, and that's this one right here, the antiderivative of tangent u. Now, the book I teach out of, I don't know about the book you're learning out of, but the one that I teach out of shows that the antiderivative of tangent is negative natural log cosine u. Other calculus books, they write the answer like this: natural log secant u plus c. Okay, and basically all it is, you see the negative here. If you bring that negative up, you would have cosine u to the negative 1, which is equal to, if you make that positive, that's 1 over cosine u, which is secant u. Okay, it's the same thing. So, I mean, when I work the problems, if I come across tangent, I'm going to write it as negative natural log cosine u for this class. Okay, because that's how we'll write it in the class I'm teaching. But just know that, you know, this means this is the same thing. And if you're in my class and you rather write it as secant u, if you remember that better, then write it like that. That's fine. And as far as my class goes, I don't care which one you write. Okay, because they're both correct. All right, so yeah, I'm not going to read through all these, but yeah, I mean, they're not really that difficult to remember. I mean, sine and cosine, students tend to know those pretty good. And then, I mean, you can see secant squared and cosecant squared, they're similar. Secant, just remember, secant squared goes with tangent, cosecant squared goes with cotangent, but you got to put the negative. And then you can see secant u tangent and cosecant cotangent, see, they're similar, secant, negative cosecant. So they won't be as hard to remember as you think, but yes, you have to memorize all of them. All right, so I've rambled on for over 4 minutes about all this, so we'll go on and get into the problems. All right, so just remember, this is all we have. Okay, if you haven't already, pause the video, write them all down so you'll have them there so you can look at them while we're going through the video. But this is what we've got to make them look like. And so what do you think we're going to let u equal? Well, probably whatever the angle is, right? Whatever we're taking the trig function of. So we're going to let u equal x squared. And so that means du is 2x dx. All right? So look, I mean, and listen, if you've been watching all these videos, that's the whole key to it, is understanding this U-substitution. We're doing the same thing with every problem. We're just letting u equal different things. Okay? Remember when we were in the logarithmic form, we let u equal the denominator. When we were doing the exponential, we let u equal the exponent. And now with the trig, we're letting u equal whatever we're taking the trig function of. All right? So you can see we've got the x dx. We're missing the 2. So multiply by 2, come out here, multiply by 1/2. And so this is going to be 1/2 integral. Let's make our substitution. That's just going to be secant squared u du. So the x squared, it got replaced with u. The 2x dx, that got replaced with du. And so, well, there you go. We got it. That's going to be 1/2. What's the antiderivative of secant squared? Well, that's tangent, right? Just look at the list you had that you paused the video and you copied down. Look at that list. And so now we have 1/2 tangent, and we got to take the x squared, plug it back in for u. X squared plus c. And there's your answer. All right. All right, so let's look at this one. We've got tangent over cosine. All right, so, well, that's strange looking, isn't it? Tangent over cosine. I don't have anything that looks like that. Do you see, if you're looking at your list, do you see anything that looks like this right here? I do. I see it. What if we wrote this as secant 2x tangent 2x dx? Man, it sure helps to know those trig identities also, doesn't it? Because isn't 1 over cosine secant? And I do have, where is it? There it is. Secant tangent is secant u. All right, so let's work it. So u is equal to 2x, and so du is 2 dx. So here we go. I've got the dx, I'm missing the 2. So multiply by 2, come out here, multiply by 1/2. And so this is going to be 1/2 integral. So the 2 x's, they get replaced with u. And then the 2 dx, that gets replaced with du. And there you have it. Secant tangent is what? That's secant plus c. And so this is going to be 1/2 secant, and u is 2x. So I'm going to replace the u with 2x plus c. And there's your answer. All right. So far, so good. Not too bad at all, is it? And look, and I'm telling you right now, every one of them's worked the same. You're just using the different formulas up there in that list. That's all you're doing. All right, what about this one? Tangent 4 theta. Do we know what the antiderivative of tangent is? Yeah, we do. The antiderivative of tangent is negative natural log cosine, or natural log secant. Remember, I talked about that one. Either way you want to put it, it doesn't matter to me. All right, so I'm going to let u equal 4 theta. du is 4 d theta. So look at this. I've got d theta. I'm missing the 4. So multiply by 4. Come out here, multiply by 1/4. And so that's going to be 1/4 integral tangent u du. See, the 4d theta, that gets replaced with du. And so we have 1/4, and this is going to be times negative natural log absolute value cosine, not theta, cosine u plus c. And so this is negative 1/4 natural log absolute value cosine, and I'm going to put 4 theta back in the place of u plus c. And for this one, the other option, you could write this as 1/4 natural log absolute value secant 4 theta plus c. So either one's acceptable there. All right. Whichever one you remember the best, whichever one's easier for you to remember, that's the one you can put as your answer on a test for my class. Okay, because they're both the same thing. All right, so how about this one? Okay, so what have we been doing? Okay, what have we been doing up to this point? We've been letting u equal this whatever we're taking the trig function of. Well, look at this. Let's just jot down right here. If you're taking notes, don't write this down just yet. So we got e to the negative x. What's the derivative of that? That's e to the negative x times the derivative of the exponent, which is negative 1. So that would be negative, right? So this would be, we would let that be u and that be du, right? But the negative, I'm sorry, dx there, the negative, that doesn't bother me so much. What bothers me is this negative x. I don't have a negative x there. I've just got e to the x. You see that? I've just got e to the x. Can we fix it? Is there something we can do so that we will have e to the negative x? Well, sure there is. We can do what? E to the negative x secant of e to the negative x dx, right? We just take this and move it up into the numerator. See, that, look, let me just say this real quick. A lot of what integrals are, or, well, mostly what integrals are, is rewriting the problem, making the problem look like one of our formulas. That's what we're doing. And if you go beyond this part of the applied calculus and you get into learn those other integration techniques after this, then you're really going to get into some rewriting problems. Okay? It may take you a whole page just to rewrite it. Okay? All right. So let's look. We've got u equal e to the negative x, letting it equal this e to the negative x. And so du is e to the negative x times the derivative of the exponent. Derivative of negative x is negative 1, so that's a negative there, and that's dx. And so, see there? There we go right there. I'm missing the negative, so I'm going to multiply by negative 1, come out here and multiply by the reciprocal. And so this is going to give me negative integral, and that's going to be secant u, e to the negative x is being replaced with u, and then the negative e to the negative x dx, see, that is being replaced with du. All right. And so, well, what's the antiderivative of secant u? Well, that's going to be negative, don't forget your negative sign, natural log, absolute value, secant u plus tangent u plus c. And so this is going to be negative, natural log, absolute value, secant, and what was u? U is e to the negative x. E to the negative x plus tangent e to the negative x plus c. And there's your answer. All right, so here we are. Evaluate 1 plus cosine x over sine x. And that's going to go from pi over 4 to pi over 6. Well, let's see. You know what? This kind of reminds me of a problem we've actually worked in the last 2 videos when we had to split the fraction up. Isn't that kind of what it looks like? So let's look at this. This is going to be pi over 6 to pi over 4, 1 over sine x, and I'm going to go ahead and split up the fraction too. Dx plus pi over 6 to pi over 4 cosine x over sine x dx. And this is going to be pi over 6 to pi over 4. Oh, look there. That is cosecant x dx plus the integral pi over 6 to pi over 4, and that's going to be cotangent x dx. Well, let me ask you this. Do we know the antiderivative of cosecant, and do we know the antiderivative of cotangent? Of course we do. It's in the list that I gave you at the beginning of the video. And we don't have to do U-substitution because it's just x right here. You see that? There's no 2x, 3x, or anything like that. So let's see, the antiderivative of cosecant is natural log absolute value cosecant x minus cotangent x. And that's from pi over 6 to pi over 4 plus, and then the antiderivative of cotangent is natural log absolute value sine x, and that's going to go from pi over 6 to pi over 4. Oh man, we got us a mess here, don't we? So let's look at that. I don't even know if we're going to have enough room to work this problem. Let's see what we got. So that's going to be natural log, that's going to be cosecant pi over 4 minus cotangent pi over 4 minus natural log cosecant pi over 6 minus cotangent pi over 6 plus, and now this one, natural log sine pi over 4 minus natural log, need to put that in absolute value, don't I? Natural log sine pi over 6. Oh, wow, look at that. So now you got to evaluate that. And just think if you had a real mean teacher and they made you give an exact value and told you you couldn't use a calculator, and I would do that. And that's something I would do on the test. I would make you do all that without a calculator, without punching anything in. All right. It's not that mean. It's not that mean to do that. But look, what I'm going to do is I'm going to go through here and I'm going to evaluate these trig values for you. And we'll replace all these with numbers. And then I'm going to write you the final answer down. I'm not going to go through and do everything. So let's just look at this. Look, we've got cosecant. Oh, well, let me move it up here. Cosecant of pi over 4. All right, that's what, 1 over sine pi over 4, which is 1 over square root of 2 over 2. That's the sine of pi over 4, which is 2 over square root of 2, which is 2 square roots of 2 over 2, which is square root of 2. All right. Remember, it's 1 times the reciprocal of that, which is that rationalized denominator. So that would actually be natural log absolute value square root of 2 minus. And then I've got the, wait a minute, what did I do there? Ah, look at that. See where I messed up? Well, I don't know why I wrote cosine. That should be cotangent. Cotangent. There we go. I had cosine written there. It should be cotangent. Well, that's easy. The cotangent of pi over 4. The tangent of pi over 4 is 1. So the reciprocal of that is 1. So that's just 1 minus, and then natural log. That's going to be cosecant of pi over 6. So let's see what we got there. Cosecant of pi over 6 is 1 over sine pi over 6, which is 1 over square root of pi over 6. That's going to be 1/2. That's 2. Okay. And so that's going to be 2 minus, and then cotangent of pi over 6. Now let's erase some of this so we can see what we've got here. I know this is a nasty problem, isn't it? So cotangent of pi over 6 is 1 over tangent pi over 6. And look, let me show you this. I know I've been doing the 1 over tangent, but look, cotangent, that's the reciprocal of tangent. So just find the tangent of pi over 6. And that's what? Square root of 3 over 3. So this is 3 over square root of 3, which is 3 square root of 3 over 3, which is square root of 3. So that's square root of 3 there. And then plus the natural log, and then the sine of pi over 4 is, that is square root of 2 over 2, minus, and then natural log, and then the sine of pi over 6, that is 1/2. And so that's what you've got there. All right. That's just going through and doing all that. And then you could, once you do everything, you would actually end up with natural log of 2 minus square root of 2 over 2 minus square root of 3. And that is by, remember, expanding and condensing logarithms. This is if you wrote all this as a single log. And I'm going to pause the video real quick and make sure that I didn't make any stupid mistakes calculating those. Okay, so I didn't make any stupid mistakes. The only thing I did is I wrote cosine here instead of cotangent. Okay, so, but yeah, there it is. You know, you would rewrite this. It would be square root of 2 over 2 times that. And I'll do it just real quick here. Natural log, that's going to be square root of 2 over 2 times square root of 2 minus 1 over, and that's going to be 1/2 times 2 minus square root of 3. If you wrote it as a single log, and then you would do some stuff to simplify that. Okay, so that's that. Okay, I'm not going to go through and work all that, but there's your answer. And if you put everything in your calculator, you would actually get, let's see, you would actually get 0.782 as an answer if you punched it all in your calculator. All right, so there's that problem. All right, now we've got the vertical velocity v in centimeters per second of the end of a vibrating rod is given by v equals 80 cosine of 20 pi t, where t is the time in seconds. Find the vertical displacement y in centimeters as a function of t if y equals 0 for t equals 0. All right, so So y is the displacement. So that actually tells us that v is equal to dy dt, right? The velocity, v is the velocity, so the velocity is the derivative of the displacement. All right. So that tells us that y is equal to the integral of 80 cosine 20 pi t dt. That's what we're looking for. Okay, that's what we want to find. So we're going to use U-Substitution, and you have probably heard me talk about this in earlier videos. We're going to let u equal whatever we let u equal. What's the derivative of this real quick, this 20 pi t? Well, the derivative, let's just write it down. U equals 20 pi t. And so we know du is equal to 20 pi dt. And notice the 80 and the 20 pi, they don't match. You see that? So remember what I've talked about? If this doesn't match this, then bring that constant outside the integral, and you've got cosine 20 pi t dt. So see, I've got the dt, I'm missing the 20 pi, so I'm going to multiply by 20 pi, so that means I need to come out here and divide by 20 pi. Just makes it easier by bringing that constant out, I think. And so we've got y is equal to, that's going to be 4 over pi, and that's going to be the integral, so that's going to be cosine u, right? And then the 20 pi dt, that's going to be replaced with du. And then what's the antiderivative of cosine? That would be sine. And so now I've got y equals 4 over pi, and u is 20 pi over t. So that's going to be the sine of 20 pi t. Okay. Whoop, and look what I did. Plus c. I forgot my plus c. That's a big no-no, isn't it? All right. So is there a way that we can find c? Well, of course. It says y is 0 when t is 0. So we're going to replace y with 0. We're going to replace t with 0. So 0 is 4 over pi times sine of 20 pi times 0 plus c. And we know that the sine, this is 0 in here. The sine of 0 is 0. So this tells me that c is equal to 0. And so we get y equals 4 over pi times the sine of 20 pi t, and c is 0. So this is your answer. All right. And that's all of the video. All right. So it's not too bad. You've just, and I didn't do an example. I didn't do an example of each one, but they're all done the same. You've got to remember these formulas. If you don't memorize them, you're not going to be able to work them. You're going to get them all wrong on your test. So make sure you memorize these things. All right. And so that's all the video. I hope you enjoyed it. Hope you learned something. Check out my other videos. Give me a like, share, subscribe. Thanks for watching, and I'll see you in the next one. Later.